Good morning to all. In the previous class, we discussed the representation of continuous time signals and operations on it. Now, in this class, just we are going to discuss how digital time signals will be represented and what operations can be made upon that one. So, let us start this session. So let us start. Now in this class we are going to begin with how to represent discrete time signals. Now just look at, so now we are starting discrete time signals. Discrete time signals. As said earlier, just one more time I am repeating that concept. Continuous time signals are continuous, but discrete time signals are digital or discrete. Digital. For example, you take from 0 to 3 time. So it takes 0, 1, 2, 3. It takes not only 1, 2, 3, but it takes all the points between 0 to 1, all the points between 1 to 2, all the points between 2 to 3. That is called continuous. Digital means, in digital sequence, 0, 3 means what? 0, 1, 2, 3. Look at the way of writing the sequence. There are no decimal values between 0, 1, between 1 to 2, between 2 to 3. It takes only integers. It takes only integers, integer values. For example, look at that. How to represent? In examinations, they will ask you. For example, look at. Here, we are using this by x of t. Here, we have to write x square brace small n like this. So these two representations are important for the difference between continuous and digital time signals. Now just look at. Here look at name of the signal is x, also x, parenthesis, square braces, small t, here small n. Small n represents only integers, make it a point. Now in examinations they ask you like that. For example, x of minus 3 is equal to 2. X of minus 2 equal to 1. Or x of minus 1 equal to 0. X of 1 equal to 2. X of 2 equal to 0. X of 3 is equal to, for example, 4, like this. In this way you can write. For example, make it or 2 or minus 2, anything, minus 2. So x of 3 equal to minus 2, x of minus 2 equal to 1, x of minus 1 equal to 0, x of 1 equal to 2, x of 2 equal to 0, x of 3 equal to 4. Now let us consider on these minus 3, minus 2, minus 1. Next one. One more point. Here one more you have include x of 0. 0 equal to 1. 1, 2, 3. So now just we are making the graph. Just look at. This is the graph. Here we are writing n. This is the vertical axis x of n. Now just look at the points. Minus 3, minus 2, minus 1 like that. So this is the origin 0. Here 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5. In this way, just we have to give the scale for the numeric integers. What is, let us make it amplitude. This is 1, this is 2, this is 3, like that. So this is minus 1, minus 2, minus 3. All these are amplitudes. Now first one look at. X of 3, minus 3 equal to minus 2. So this is x of minus 3, left side, minus 3. Its value equal to minus 2. Minus 2 means what? Up to this level. So now just we have to make it like this. Look at this, just bubble type. Digital. X of minus 2 equal to 1, positive 1. Positive 1 means here minus 2. Up to this level, look at, up to the level 1. X of minus 1 equal to 0. 0 means on the same axis itself. X of 0 equal to 1. 1 means here, x of 0. Make it x of 0. X of 1 equal to 2. This is x of 1. 1 equal to 2 means up to this point. X of 1 equal to 2. X of 2 equal to 0 on the axis. Make it bubble on the axis itself. X of 3 equal to 4. Like this. So let it be 4. Now x of 3 equal to 4. Now just look at, this is the representation of digital signal, time signal. Look at, only digital. The spikes are only at integers. There is no spike between integer to integer. That is called discrete or digital. For example, just look at one more point. Now in the continuous time signal, this is t. This is x of t. For example, we are representing amplitude equal to 2. We represented a graph like this. This is 0, 1, 2, 3, 4, 5, 6. Look at, this is a continuous time signal. It is represented by small t and x of t. Its amplitude equal to 2. The same continuous signal, how can we represent in discrete time signal? Now just look at, same, now we are converting the same into discrete. We are converting into discrete time signal. In the discrete time signal, we are taking the same graph, just look at. We are taking the same graph, look at. But here small t, we are converting into discrete, so use small n. Here continuous x of t, but this is discrete, so use x of square brace small n. Use the same description of integers 0, 1, 2, 3, 4, 5. Amplitude 1, amplitude 2. Now just look at, this is a rectangular signal. In which one? Continuous time signal. The same signal we are going to represent in which way? In discrete time signal. Now just look at, what is its amplitude? 2. So between them, take the middle one, the highest 2 spike. Remaining 2, just a little bit smaller than the height of the previous one. Now the last one a little bit than this one too. Now just look at, this is the representation of the discrete time signal. Students have to understand and notice this one. Just look at, the middle one is always highest. It is on par with the amplitude. The remaining next one, heights of these two spikes are same. Heights of these spikes are same. Now just look at, this is the way of representing a discrete signal. For example, look at another one. You are making, this is a continuous time signal. This is x of t. Now here in the x of t, you can make it a signal like this. For example, this is minus 2, minus 1, 0, 1, 2. Amplitude equal to, for example, 3. This is 2. This is 1. Now look at, this is a continuous time signal. Now how to represent the same signal in discrete time signal? Now just look at here. What is the width of this signal? Just look at width of the signal, that is equal to minus 2 to 2. Now in the previous example also, what is the width of this continuous time signal? This width of continuous time signal, that is equal to from 1 to 5. Now just look at, now what is the width of this digital? This x of n, that is equal to 1, 2, 3, 4, 5. Now students have to understand, here I use x of t belongs to 1 comma 5 square braces, but here curly braces, it represents a sequence. Now same, there is no change in the width. Similarly, what is the width of this continuous signal? Minus 2 to 2. So discrete signals width will also be like that. There will be no change. Now here just we are writing the same thing. Now we are writing what? Discrete. Discrete. Now first take the same graph as it is. Now just, but here we are using n, here we are using x of n. This is the difference. Now what will be the width of the digital? Same width. So the width of this digital equal to x of n, that is equal to curl brace of which one? Minus 2, 1, 0, 1, 2. Width never changes. Now make scale upon this one. 0, 1, 2, 3. Minus 1, minus 2, minus 3. Now just look at. What is the width? Minus 2, 1, 0, 1. What is the amplitude? 3. Here also amplitude 3. Now just look at. The middle one, 0 will be, I am making a bubble on it, look at 0. Next to 1. Here also same height 1. Next 2, 2. Just look at. Now just look at. This represents digital. Among these 5, the middle reaches on par with the amplitude. The next 2 spikes are same. These 2 spikes are height is same. Height is same. Look at in the same way, the middle one always reaches the amplitude. Right side of the middle one, left side of the middle one, next same height. The last 2 will be the same height. In this way, students have to make the height adjustments of the spikes. That is the way of representing discrete time signal. In discrete time signal, converting discrete to continuous or vice versa, there will be no change in the width of the signal. Only representation changes. Here it is continuous. Continuous means what? Continuous means a straight line. For example, look at this is continuous. For example, minus 5 to 6, continuous. This is continuous. Discrete means same minus 5, that equal to 6, but no straight line, dots, only integers. This is called discrete. That is the way of representing the difference between continuous and discrete. So this is the way of representing discrete time signals from continuous time signals. We can change either of one from the other one also. So now here students come to know how to make digital to continuous and continuous to digital signals. One more example, very easy to understand. For example, just look at, this is the sine curve. This is the sine curve. Continuous, because continuous line is there, so continuous. How to make it digital? Digital means same, just look at, make the same graph, but now just look at, this is the way of describing in digital. So one thing, just that thing you have to make it very important. So digital is, you have to understand that no continuous or decimal point will be touched. Only integers. The spikes will be risen only at the integers only, not at the decimals. But continuous means it includes both integers as well as decimal values. That is the difference between continuous time signals and discrete time signals.